We previously looked at hypothesis testing for the mean when the sample comes from a population that is normally distributed. If, however, we are told that the population is not normal, or even we are not told, but there is no reason to believe that it's normal, and the sample size is large enough to invoke the central limit theorem, and big enough sample means n bigger than 30, then we should explicitly refer to the central limit theorem, not just say vaguely big enough sample. So central limit theorem allows us to make decisions, and we know that the mean of the sample will be normally distributed with the same mean as the mean of the population and the standard deviation or the variance sigma square over n, where mu is the mean of the parent population and sigma is the standard deviation of the parent population that, I repeat, is not normal. Also, it might happen that we actually do not know the standard deviation of the parent population, and that's the case in the majority of the times. Therefore, we can estimate the standard deviation of the parent population by using the unbiased estimate of the variance based on the large sample. So as you see, there are quite a few concepts that come here in these types of problems. So central limit theorem comes in place and estimates for the variance of the population. We might have other cases when the statistical variable follows a binomial distribution or a Poisson distribution. What to do in those cases? When the conditions are met for the binomial or Poisson distributions to be approximated by a normal distribution, we might set up hypothesis testing using the normal distribution. In the case of the binomial distribution, when these conditions are met, we construct the distribution of the sample proportions, and this is a distribution we are looking at to do hypothesis testing. A reminder for you that this is from your formula booklet. So you have, and also that I made a mistake here, that's normally distributed, not binomial. And so the formula for the approximate distribution of sample proportion is in your formula booklet. Cp and Q is 1 minus P. That's a variance, and I like to write it as variance squared, standard deviation squared. In the case when the variable is Poisson, under this condition, the Poisson distribution can be estimated with a normal distribution. And of course, for the normal, the mean is the same as the mean of the Poisson, and the standard deviation or the variance is the same as the variance of the Poisson distribution. So we use these sampling distributions for hypothesis testing. In none of these cases we need to use continuity corrections as you will construct critical values. Please stop the movie and try the question by yourself before looking at the solution. Let's read the question and explain a bit the solution. So, the college thinks that the average time for a student is about half an hour, meaning that the H0 hypothesis is average time mu is 30 minutes, where x is travel time. Always make it clear what the variable measures. Now, if you read the next part, H1 will be mu is not equal to 30. So it's a two-tail test. If we are told, for example, that some travel arrangements were put in place, we'd hope that this one would increase or will decrease the time taken. So therefore H1 would have been mu smaller than 30, but it's not the case here. If you read further, the data is given in summarized forms. This will help us to calculate unbiased estimate for the variance and to find the mean, which are here. You look at the formula, at the previous formula. I want to insist on the second question. Test at 5% significance level whether the mean travel is half an hour. So, we are not told what is the distribution of the travel time. But because the sample is big enough and is 80, so it's bigger than 30, then accordingly to the central limit theorem, I can say that the mean travel time is normally distributed with the mean 32.8 and the standard deviation or the variance 129.3 over 80. So that's a variance. Later on in the movie, I saw that I made a mistake, so I'm coming back here. The mean is 30. 32.8 is the mean of the sample, but we are under H0, so under H0, this is the mean. So we are going to work with 30. And very often, I mean always actually, you need to make it clear that you use central limit theorem and this is your sampling distribution. So this is called sampling distribution. This is a distribution where my test statistic lies. And now the problem becomes more obvious. Test a 5% significance level whether the travel time is or not half an hour. On my distribution now, I have my distribution. 5% significance level means that I need 2.5% here and 2.5% on the other side. Therefore, that will be a region where I accept H0, and that will be the critical region or the rejection region where we reject H0. Otherwise, see, all these formulae become meaningless without a diagram and without understanding the steps that we are taking. Where from this formulae come? So, look here. If you look at first method would look at the standard normal distribution. So this is Z. Normally distributed is 0, 1. If you look at standard normal distribution, you look at the critical values here, which gives you an area of 2.5% here and 2.5% here. So if you look in your table of values, you'd find here 1.96. And you want to see where your test statistic is. So your test statistic will be X bar minus mu over the standard deviation, but the standard deviation of my new distribution. So 32.8, no, sorry, this is, so we have 32.8, the mean of the sample, minus the mean of the population under H0 over square root of 129.3 over 80. And this will give me 2.20. Therefore, this is a test statistic. So the test statistic is in the rejection region, is bigger than 1.96. It's in the critical region. Therefore, we'd say that we reject H0. The method that is presented under the second method 2 brings, what it does is that it takes the critical values and moves the critical values on the sampling distribution to compare them then with 32.8. So in the second method, this point here, which is the left's critical value, is related by this point here, let me call it A, by the formula minus 1.96, which is here, equals XA, which I don't know, minus mu over square root of 129.3 over 80. And this allows me to find A. So A will be 27.5. So this point here on the sampling distribution is 27.5. For the second point, I'll call this B here, 1.96 will be B minus 30 over square root of 129 over 3. And after the calculation, P is 32.3. So now if I'm looking at the statistic, which is 32.8, 32.8 is after B. So I'm redrawing this diagram here. It became a bit messy. So that's my A, 27.5. That's my B, 32.3. This area here is 2.5%. This area here is 2.5%. And your test statistic on this distribution is 32.8, so it's here. It is again in the rejection region. So this is acceptance region and this is the rejection region, or the critical region. So 32.8 is in the critical region. Therefore, your conclusion will be that you reject H0, and you will say there is enough evidence at 5% significance level to reject H0. Therefore, to conclude that the travel time for the students is not half an hour. One last comment from me is that you need to understand the concept. Once you understand the concept, you have many ways to find your solution and to build your solution. As long as you show enough working and you show your thinking with diagrams, well, that probably not as messy as mine here, then your solution will get full marks. This question here also deserves a bit of your time, so please stop the movie and try it by yourself. When one sees this solution, would wonder where from all those numbers come. So I like how the question was started, how the solution was started. X is a number of questions Novak answers. It's very good to label what X means. Then X is binomially distributed with 50 and P. Because there are 50 questions, P is the probability of guessing. Novak feels that he knows a lot, but the teacher probably thinks that he's guessing the answers, right? So P equals 0.2, he will guess 1 out of 5, so 20%. It's a proportion. 20% of the answers he can guess if he doesn't know anything about the subject. H1 is P bigger than 0.2 because he feels that he knows enough of the subject matter. What the solution is missing is, in this case, because X is binomial with 50 and I'm under H0, 0.2, then I estimate this with a proportion which is normally distributed with 0.2 and square root of 0.2 times 0.8, remember PQ, over 50 squared. I always like to write like this so that I know that that's a standard deviation and that with a square is a variance. So now on this distribution, I'll do this hypothesis testing, and it's a one-tail test. This is a distribution of the proportion, the sampling distribution of the proportions. So see, it's not of the means as we are used to, because I'm looking at the proportion. So that's a sampling distribution of the proportion. I have on 1% significance level, right tail, so this is 1%. On this normal distribution, I will need to look here at the critical value. Once I find the critical value, I compare it. I can compare it with 18 out of 50, which is 0.36. So this is my test statistic. My test statistic is 0.36. Or I can standardize and I can look at Z, which is normally distributed of 0.1. And I can look at the critical value on this distribution. So critical value on this distribution will correspond also with 1% on this side and 99% on the left-hand side. So if I look at the critical value on the standard normal, I can bring it back here with Z equals X minus mu over sigma, which is a general formula. And we need to adapt it to the question there. So that's where from this strange number comes. And you don't need to do all of this in one go. You just scaffold your thinking and take them step by step. And this is another question I'm asking you to think of. Stop the movie, please. Now we're more used to what to do. And at certain stages, like for example here, stop and think where from these numbers are taken and scaffold your solutions so that it makes sense for someone who reads it. This question is on type 1, type 2 error, so you might refer to one of our previous lessons where we learned those concepts.